Hello and welcome to this presentation for Theme 3 of A-Level Business. This one is on quantitative sales forecasting and is going to be about 4-quarter moving averages and seasonal variations. So what you need to be able to do is use time series analysis to calculate 4-quarter moving averages. You need to adjust your forecast to reflect cyclical or seasonal variations, and you need to be able to explain the limitations of time series analysis. So, on the previous video that you watched about time series analysis, we calculated 3-period moving averages to help us to smooth out variations in data. For instance, in the table here, we look at the period from 2003 to 2005, the sales data is 67 million, 70 million and 64 million. So it's a little bit up and down. But we can smooth that out by calculating the 3-point moving average. And if you remember, the way that we do that is to sum the data for those 3 periods. So 67 add 70 add 64 gives us 201, and then to convert that to an average we divide by 3, and that gives us, for that three-year period, a 3-point moving average of 67. And then what we do is we continue down the table. So the first year drops out and we look at the period 2004, 5 and 6. We sum the sales data for that period, add it up together, divide it by 3, and that gives us our next 3-point moving average of 65. So we're going to do something that's quite similar to that, but instead of looking at a 3-point moving average, we're going to look at a 4-point or 4-period moving average. So I'll show you how to do that now. So when you're doing 3-period moving averages, it's very easy to center because we're using an odd number, so it's easy to find the center. So for instance, if we're looking at period 1, 2 and 3, we would center at period 2 because that's in the middle. It's a little bit more tricky when we're looking at 4 periods, 1, 2, 3, 4. And it's very common for businesses to do 4-quarter moving averages because they often collect data using quarters, so using 3-month periods. So they might look at sales data per quarter, particularly if it's a seasonal business, and it will often calculate cost data per quarter. So it's quite common to need to do this 4-quarter moving averages, but it's a little bit more tricky to do, so I'll show you how to do it now. So first of all, it's quite similar in a way to what we did on the previous presentation. What we've got here on the left is the years, and this time the years have been divided up into quarters. So we've got the time periods here on the left. And then in column 3, we've got the sales data, and this time it's in thousands of pounds. So what we need to do first is we need to complete column 4. Now that is a little bit different than what you did on the previous presentation. So this time you're going to do something called calculating a 4-quarter moving total, and that is very easy to do. So you take your first 4 quarters, 1, 2, 3 and 4, and you look at the sales data for those periods. So we've got 120,000, 140,000, 190,000 and 130,000, and we simply sum them up to get our 4-quarter total, and we write that here. As you can see, 120 add 140, add 190, add 130 gives us 580, and we write that in here. And it's written in the middle there because it's in between the 4-year period that's being considered. 1, 2, 3, 4, so it's written roughly in the middle there between years 2 and 3. So that's our 4-quarter moving total for the first 4 periods. So then we drop down. So we drop out the first period, just like we did in the previous presentation, and we move down. And we look at periods 2, 3 and 4 of 2012, but we add in period 1 or quarter 1 of 2013. So that means that we're adding sales of 140, 190, 130, 130. So we sum those up, and that gives us our next 4-quarter moving total that you can see here is 590. So that's the second step that you need to do, is you move down the table and carry out the next, calculate the next 4-quarter moving total. So then we need to move on, and we need to complete, column 5. So column 5 is to calculate the 8-quarter moving total. So the way that we do that is we take our 2 4-quarter moving totals and we simply add them together, and that gives us our 8-quarter moving total. Now it's called an 8-quarter moving total because it has 8 periods worth of data to work this figure out, because we've got 1, 2, 3 and 4 contributing to this figure, and we've got 1, 2, 3 and 4 contributing to this figure. So these two figures are based on 8 periods of data, so this, the sum of them, is the 8-quarter moving total. And then we do our next step, which is to complete column 6. And what we do to complete column 6 is calculate the 4-quarter moving average. And very simply, you take your 8-quarter moving total from column 5 and you divide it by 8 to convert it to an average, because remember, it's based on 8 periods worth of data. 1, 2, 3, 4 and 1, 2, 3, 4. So we divide by 8 and that gives us our 4-quarter moving average. And to continue, you simply move down the table and do the same thing again. Now, this first moving average is centered here in Q3 of 2012. This is because it's based on data from all of these 5 periods. 1, 2, 3, 4, 5. And the middle of those is quarter 3. So that's why it's centered in Q3 of 2012. And when we plot it, we'll plot that against Q3 of 2012. That's where it will be plotted in the graph. Okay, so what I would like you to do now is just pause the video and try to work out the next 4-quarter moving averages. So you'll need to calculate 2 8-quarter moving totals, and then you will need to average them by dividing them by 8 to calculate these 2 4-quarter moving averages. So I want you to fill in these 4 boxes. So please pause the video now and see if you can do that. So how did you get on? So hopefully what you did was you took your 2 4-quarter moving totals and you summed them up to give you your 8-quarter moving total here, and then you divided that by 8 to get your next 4-quarter moving average. And then you did the same again here. You added 640 to 670 to get your 8-quarter moving total here, 1,310, and then you divided that by 8 to get your 4-quarter moving average here. Hopefully that's what you've done. Okay, so let's take a look at this data plotted on a graph. So when we're plotting the graph, we'll be plotting the time period, and we'll also plot the raw sales data so that you can see what that looks like, and then we'll plot the 4-quarter moving average, which is the trend, where the fluctuations in the data have been smoothed out by averaging them across time. So, same as in the previous presentation, on the x-axis here, you've got the time periods, and this is by year and quarter. And then on the y-axis, we've got the sales information in thousands of pounds. And this blue line here shows the raw sales data. So it's very volatile, very, very up and down, isn't it? And then you've got this red line here. And the red line is the 4-quarter moving average line, the smoothed out average that we worked out on the previous slide. So we worked out the first 4 together, and then I worked out the rest and plotted them on a graph. So you can see the overall trend is very clearly upwards, and all the lumps and bumps have been smoothed out. Now we can use that trend line to actually draw a line of best fit and extrapolate it to forecast future sales, just like we've previously done. So there you are, there's a line of best fit added, and then it's extrapolated, so if we need to read off a forecast from another time period, then we can do that. For instance, if we wanted to forecast sales for Q3 of 2016, we simply read along the x-axis to Q3 2016, and we read up to our line of best fit, and then we read across to the y-axis, the sales axis, and it tells us it's around about 216,000 is what we could expect sales to be in Q3 of 2016. So that's how you would use your line of best fit. Now, we've got that figure, 216, that we read off from about here. But, and it's a big but, this data is clearly very, very seasonal. So I think it makes sense, and I'm sure you'll agree, to say, well, Q3 2016, what do we know about Q3? Well, we know here, looking at this data, look here, Q1, Q2, Q3. Wow, and Q3 sales have peaked here. Q4, Q1, Q2, Q3. Sales have peaked again. Q4, Q1, Q2, Q3. So we can clearly see a pattern that every third quarter sales peak for this business. So to simply work out our forecast by reading up to the line of best fit and reading across to the sales axis doesn't seem like enough. It makes sense that we need to adjust our forecast to reflect the fact that in every third quarter for this business, sales are significantly above trend. And that's what I'm going to show you how to do now. It's very easy to do. Excuse me. So, we've been asked to forecast sales for Q3 of 2016. So we need to work out something called the average cyclical variation. So that means we're going to work out, on average, in the third quarter, how much do sales deviate from trend. So, here's the data that we've been considering, and I've completed it all to show you all the 4-quarter moving averages. So that's all the 4-quarter moving averages all filled in for you. So what we need to do now is fill in column 7. So the way that we fill in column 7 is by calculating the cyclical variation for each time period that we are considering. And we're going to use this formula here. Variation equals actual data minus trend data. So we're only going to look at quarter 3 because we're trying to forecast for quarter 3. So let's look at 2012 quarter 3. The actual sales figure for that period was 190. Our trend figure, or 4-quarter moving average, also known as the trend, was only 146.3. So it's low, isn't it? So the variation, sales minus trend, is the variation, which is 43.7. And then we go down and we do the same for Q3 here. So we look at 2013 this time, we look at Q3, actual sales minus the trend to see what the variation is in that period or that cycle, that quarter. And it's 52.5, higher than our trend level of sales. The same again for 2014. Take a look at the third quarter. Here's the level of sales, 240. Here's our trend figure, it's lower again. And here's a variation from trend. So in that period, sales were actually nearly 59,000 higher than the trend. Okay, so the next thing that you need to do is complete column 8 by calculating the average cyclical variation. And that's very easy. We take each cyclical variation for each one of these quarters and we sum them up. 43.7, add 52.5, add 58.8, and we work out the average. So because we had 3 pieces of data, we divide by 3, and that gives us our average cyclical variation for Q3 of 51.67. So that means on average in Q3, sales are about 51,000 higher in the third quarter than the trend would suggest. So what we need to do is then adjust our forecast. So we worked out our forecast, which we read off from our line of best fit, was that in Q3 2016 sales would be 216,000. But we know that's too low. Q3 is a period with peak sales. On average, in the third quarter, sales are 51,670 higher than trend. So we need to add that on. That's how we adjust our forecast to reflect the cyclical variation. And that gives us a more accurate figure for the forecast of £267,670. So that is what you need to do. Those are the steps you need to go through to adjust your forecast for cyclical variation. So what I'd like you to do now, please, and I'll put all the steps back on so you can use them. I'd like you to pause the video now and carry out your own analysis. So what I want you to do is work out the average cyclical variation, not for Q3 this time, where sales were really very high compared to trend. I want you to work out the average cyclical variation for Q1. Okay, so what you need to do, remember, take your actual sales figure, subtract your trend for each of the Q1 periods, and then work out the average. So pause the video now, please, and complete those 4 boxes that are on the screen. It might be useful for you to print this slide off to use. Okay, how did you get on? So hopefully you have those figures in front of you now. So there's the actual sales for Q1, there's the trend sales, and this time the trend is actually higher than the actual sales, so the cyclical variation is negative. Typically at that period in Q1 sales will be below trend, and the same here for Q1 of 2014. Here are the sales, here's the trend is higher than actual sales, so our cyclical variation is negative again. And the same again, Q1 here. Sales 160,000, trend sales 191,000. So again, our cyclical variation is negative. So you take those 3 figures, you add them together, and then you divide by 3, and that gives you the average cyclical variation for Q1. So in Q1 periods, on average, sales will be about 33,000 lower than trend. Okay, so then you would use that figure by subtracting that amount from your forecast if you were doing a Q1 forecast. Okay, so let's move on. So what you needed to be able to do was calculate 4-quarter moving averages. Hopefully you understand the method, and we'll do some practice in class. You also needed to be able to adjust your forecast to reflect cyclical or seasonal variations in sales. So hopefully you now know how to work out those average variations and either add them on or take them away from forecast to adjust your forecast to reflect any variations in that time period. Now we need to briefly look at the limitations of time series analysis. So let's do that now. So first, very obviously, the past is not always a good indication of the future, and the more dynamic the market, the more true that will be. Important to bear in mind as well that sales will be influenced by external influences, and those can be difficult to accurately predict. So think pestle. I know you've been doing pestle in your other lessons, so you know what that means. So all of those things might change and affect the accuracy of forecasting. Remember, lots of unexpected events might occur. For instance, there might be a change in the competitiveness of the market. Maybe a new entrant joins the market that you weren't expecting. Maybe you experience supplier failure and that affects your ability to produce your products at your current price. Bear in mind as well that there is always a risk of some kind of manipulation or bias in the data. Sometimes managers are using sales forecasts to try to persuade their colleagues to go ahead with maintaining a product, with a product launch, and so there might be a risk of bias in the way that the data is presented or calculated. Other thing to bear in mind is how good quality is the data. Is the sales data that you're using accurate? Has it been collected digitally? Can we really trust how good the data is? Last thing to bear in mind, remember, the further into the future that we're trying to forecast, the greater the degree of uncertainty. If we're trying to forecast only 6-7 months ahead, it's much more likely to be accurate than if we're trying to predict maybe 5 years into the future. Okay, so those are the things that you needed to be able to do. Hopefully you are able to do them now. Thank you for listening.